In today's video, we bring together a range of ideas and techniques that lead to an ordered and systematic checklist for sketching a curve in the plane. We begin by making some general remarks about curve sketching, by which we mean drawing the graph of the function y is equal to fx in the xy plane. Always aim for simplicity and clarity and focus on the main qualitative features. Extra details such as coordinates of points can be added depending on the requirements of any particular problem. So let's get started. As we proceed, I have made a natural list of typical features to look for. First, look for the y-intercept where the curve crosses the vertical axis. First, we have to look for the y-intercept. And what is y-intercept? It is the point where the curve passes the vertical axis, and this is usually pretty easy to find. It is usually pretty easy to find. You just have to do f of 0, or you just have to calculate what is f of 0. Second thing we have to do is to calculate the x-intercept. And what is x-intercept? Where the curve crosses horizontal axis, where the curve crosses horizontal axis. If they are likely to be straightforward to find, then it is a win-win situation for us, but they may be difficult as they are the solutions of the equation f of x is equal to 0. And solving this may get tricky, or we may have to use approximations, but we don't have to worry much as we are looking for a rough sketch and even might skip it. The third thing we have to look in the curve sketching procedure is asymptotic behavior. Asymptotic behavior. What do I mean by asymptotic behavior is when things get large. Even in our algebraic function, when things get large, it just reminds us whether it is asymptotic or not. It should click us. So there are various possibilities. A, what happens as, we have to see what happens as x tends to infinity is, or x tends to minus infinity. This will lead to possible asymptotes. So wait a second, let me get some space here. Yes, we are back. B, what we have to look forward is, are there any vertical asymptotes? Are there any vertical asymptotes? For this, we have to look near which y tends to infinity or y tends to minus infinity. This is our step number 3. In step number 4, we have to check where the curve is increasing or decreasing. So what do I mean by the word increasing and decreasing? It's nothing, just we have to check where the first derivative of our function is greater than 0, implies the curve is increasing, and wherever the first derivative is less than 0, implies the curve is decreasing. So we have to just check for these, and we will find out whether our curve is increasing or decreasing, and we find it to locate the turning points. To locate the turning points. For this, we have to search for the point where y dash first derivative is equal to 0. After locating the turning points, we need to exploit the sign diagram for y dash, which could help us to locate the possible local or global maxima slash minima. So next step is exploiting the sign diagram for y dash. This is our next step. From this we can tell the global maxima, minima, or the local maxima and minima. So what do I mean by maxima? Means something curved like this, having this point as a global slash local maxima, and we can also predict minima using the turning points, a curve like this, and this is our global minima or local minima point. The fourth step which we need to, the fifth step which we need to check, and it is the last step guys, we have to check where the curve is concave up or concave down. For checking where the curve is concave up, we usually check if the second derivative of the function is greater than 0, we say the curve is concave up, and if the second derivative of the function is less than 0, we say the curve is concave down. Wait a second, yes. And with this second derivative, we also used to look, or we also try to locate points of inflection. Or y double dash is equal to 0. Point of inflection. So what is the point of inflection? Basically, point of inflection is the point where concavity of a function changes, and hence exploit the sign diagram for y double dash is equal to 0 in search of these points. So exploiting the sign diagram for y double dash in search of the inflection points. Something like this. Let me draw something like this. A point where a function changes its concavity is our inflection point, right? So in this given figures, this is our inflection point. The curve changes infinity. In this is also inflection point, and this is also an inflection point. So that's it guys. These are the basic 5 steps to apply for curve sketching, and this is the basic procedure for this video. And in the next video we will do more examples in which we will apply all these 5 rules and try to draw more curves of basic polynomials, cubic, quadratic, and more so on. And that's it. We'll see you guys in our next video.